All right, we're going to talk about some of the work that you guys submitted on this Do It Two Ways worksheet. Here were the questions. Now here was some of the results. For number one, solving by quadratic formula should always work, but you should consider factoring. What I thought was interesting is this factoring by grouping. This is how you were really first taught in Algebra 1 how to group around here. But I do want you to consider that at this point, you could just guess and check, it's called. Okay, so you find two numbers that multiply to 4, you find two numbers that multiply to 10, and you do match them up to make a 3 in the middle. So if I chose 1 and 4, I know 4 times the 2 would make 8, and 1 times the 5 would make a 5. So a negative 8 and a positive 5 will give you the same result as doing it by grouping. Eventually, it's supposed to be quicker to do it by guess and check. So that is something you want to consider letting go of grouping. I know factoring is one thing I didn't really do any kind of review on this year. So we'll see if you can do some problems as we move forward. This second one, the HK form looks nice, and then foiling it out was the two ways to write that answer. I believe this one's actually number 3. So the original problem, you can literally, I don't know if I'd say use chain rule, I'd say use power rule here. Once you say you're going to take the derivative, you're going to do the power rule. And then try to do the chain rule, but there is no the derivative of the inside is 1, so you didn't need it. By distributing first, you're taking y and you're still cleaning it up. And now you're going to take the derivative of y, is how you'd write that, to get the same answer. I'm going to skip to 5. Factoring, difference of squares. Most of us took out the GCF and did it by difference of squares. And then some people did forget the other way to do it. So there is long division. There's another option here. And we do have the synthetic division option. And what I love is that the person that did synthetic first had an error. And because they knew the answer, they went back and figured out their error and fixed it. So that was kind of the point. Here with this number 5, the problem is it's not equivalent here to here, okay? And because those are not equivalent, the work does not support the answer. So I just wanted to make sure we saw that. And one more, number 5. Just this number 5 never showed a second option. So, you know, I'm doing these assignments not to just keep you busy. I do really want to see how your thoughts are going and if you're really keeping track of things. Number 6 did give people the most trouble. I guess we'll go with this one. So in number 6, quotient rule was the most obvious way to approach it, I thought. And this work shows the derivative. Well, I would write that this is the original. So I would write this is the original. And then I would say the derivative of this original is, you know, derivative of the top times the bottom minus top times derivative of the bottom all over the bottom squared. So once you clean that up, you shouldn't have an issue. Product rule you were doing by taking the original and then rewriting it as 2 plus 3x times 5x to the negative 1 power. And now you're about to find its derivative. So when you moved it up, for instance, here, make sure you're putting the negative 1 on the outside because that really does change a lot of the work. For instance, here, this person did write it correctly, but you didn't actually take the derivative yet, I don't think. You're about to take the derivative. But what's concerning is you're kind of just taking the derivative of both of them at the same time. So you got to remember your rules. So, for instance, this number 6, I'm just a little, I don't know, I've never really just taken out the 1/5 like that and written it as divide by 5. That looks a little confusing. And I know you're taking the derivative of 3x plus 2, which is the same as 3 times the derivative of x. But you're really making your life difficult. Why don't you just say the derivative of 3x plus 2 is 3? So I'm not sure all the time if you guys are just writing what someone else is telling you to write or if you're doing that yourself. But it seems a little overkill to do all this unless So I do want you to really make sure that you're, trying these problems and making sure you're comfortable with the process. I know a lot of you are getting ready for your college placement tests. So I did just actually put a new practice test up there as well for you guys. So keep those things in mind. If you want some help, just keep me in the loop. Now here, this common mistake was when you did the derivative the first times the second, you actually tried to combine this, okay? You cannot combine this, specifically because that -1 was supposed to be on the outside. So that -1 really did seem to mess up some people. And here, I do like the idea of considering breaking this into two separate fractions. So this is still not the derivative, though. You haven't done the derivative, but you have simplified the problem, okay? Now you're going to find the derivative, and the derivative of this is the 3/5 is 0, and the derivative of this, again, this is not really showing much work. To take the derivative of 2 over 5 times x to the -1. Notice this time you only have to bring up the x. From there, the derivative, you could say, is -2/5 x to the -2. And so that's how you're going to be getting the same answer. So just little points there to be mindful of. I did also notice with number 6, again, this this method of using the definition, no one else had thought to do that. Basically, that is the first way you learn to do a derivative. So that was nice to see. Even though even here I feel like people are maybe getting their answers off the internet instead of trying them themselves. So you guys are going to have to let me know what you have questions on. I don't want to just give you busy work. I'm really trying to still improve your skills. When you get to number 7, a lot of people put an upside down parabola, which is absolutely concave down, but it's increasing and then it's decreasing, so it's not monotonic. So here were some nice examples for number 7 that were concave down and monotonic. Number 8, here someone took the time to show me how they got B. They just never actually finished solving it out. And then 3 was in the middle of the range. I know there was a typo where I told you what the amp was, but with the range being -1 to 7, the middle had to be a 3 with an amp of 4. So everything else looks good here, and we'll move on to something else next.